Hey everybody, welcome back. This is the lecture on section 11.4, what's called quadratic form. And in this section we're going to be using our ability to solve quadratic equations and expanding that into a larger class of equations for us to solve. So let's do a little bit of a recap here. Whoa, that's a little thick, Jack. Let's do a bit of a recap here. For a quadratic equation. It doesn't look black, that looks blue. Hold on one second. There we go. For a quadratic equation, of the form ax squared plus bx plus c equals 0, we have three options. We have three options for solving. One, if you can, factor into a product of binomials and then use the zero product property. And that might look something like this, right? Like 4x squared minus 3x plus 1 is equal to 0. And you might say, well, that's, let's see, that's like a 4x and an x and a 1 and a 1 and something like 4x plus 1 and x minus 1 equals 0. And that allows you to break this up as 4x plus 1 equals 0, or x minus 1 equals 0, in which case x is equal to negative 1/4, or x is equal to 1. Your second option, 2, is to complete the square. And I'm not going to go into that too much here, because that is just the road to quadratic formula, where you would say, well, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And it's option 1 and 3 that we're really going to focus on in this section, but we're not going to be doing it with quadratic equations per se. We're going to do it with what are called quadratic type equations. Quadratic, come on, handwriting. Quadratic type equations, or as this section calls it, quadratic form. And what we're talking about is not ax squared plus bx plus c equals 0. This is quadratic. But what we're talking about is something like a, and this is going to be a little bit weird at first, u squared plus b times u plus c equals 0, where u can be anything. In which case we can use techniques 1, factoring, or techniques 3 for quadratic formula to solve for u. And so here we have different variations based upon u. For example, what we're really looking for is something of the form a times something squared plus b times that something plus c equals 0. So, for example, let's see, 4x to the 4th power minus 3x. Whoops, did I have a plus 1 back in that example? This is a minus 1 here. My bad. Shh, that never happened. 4x to the 4th minus 3x squared minus 1 equals 0. Now, it's not quadratic. This is not quadratic because it is not x squared. It's x to the fourth. However, we can rewrite this as 4 times x squared squared minus 3 times x squared to the first power minus 1 equals 0. And it's not quadratic in x, it's quadratic in x squared, so we might do a little substitution, like let u equal x squared, so that this becomes 4 times something squared minus 3 times that same thing to the first power minus 1 equals 0, where we have u and u here. So this is quadratic in u, or quadratic like or type forms. And so we can factor this, or we can use quadratic formula. Using quadratic formula. I know we factored this same one last time, but using quadratic formula, we have u is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where in this particular case, oops, I need a fatter marker than that. Come on. There we go. Oh, that's a terrible color. A is equal to 4. B is equal to negative 3. C is equal to negative 1. Let's switch back to black here. And this gives us negative 3 plus or minus the square root of negative 3 squared minus 4 times negative 1. So in this sense, it's very much just like using the good old-fashioned quadratic formula, with one small hiccup at the end. This is 2 times 4. And what we get is 3 plus or minus the square root of 9 plus 16 all over 8, which is 3 plus or minus 5, because 9 and 16 is 25, and the square root of 25 is 5, over 8. And this is either negative 2 over 8 or 8 over 8, which, as we saw before, was negative 4, 1/4, and 1. However, but these are u values, not x values. And we want to solve for x. So either u equals negative 1/4 or u equals 1. But according to our substitution back here, u is equal to x squared. So x squared equals negative 1/4, or x squared is equal to 1. And now I can use the square root property that says x is plus or minus the square root of negative 1/4, or x is plus or minus the square root of 1. Now this is easy enough. This is just plus or minus 1 on the right side. On the left side, this is plus or minus the square root of negative 1 over the square root of 4, which is plus or minus I over 2, or in this case, plus or minus 1/2 I is an imaginary number. So we do have a couple of imaginary values, but values for x nonetheless. And so what happened here was we started off with something that wasn't quadratic, but we could rewrite in a quadratic type scenario. We did a little substitution there, and we replaced, in this case, x squared with u, making x squared squared u squared. And then we solved for u, and then when we were done solving for u, we substituted back and we got x squared for u, and then we solved those individual equations. So what are we looking for here? So in general, whenever you have something of a x to the 2n plus b x to the n plus c equals 0, and that's not a good color for highlighting. Hold on a second. Let's go pastel. And this color, this power, whatever this is exactly half of the other one. So as long as these powers are, how do we want to say this? Either as long as these powers are such that the middle, quote unquote, middle power of x is exactly half of the leading power of x, we can use this technique. And in that case, we're always going to let u, or whatever letter you want to use, u equal that middle power, x to the n. So what do I mean by that? Well, let's take a look at some quick examples, some quick rundowns here. 5x to the 20th plus 2x to the 10th plus 8 equals 0. This is quadratic type, or has quadratic form, because this power and this power are related by a factor of a half or a factor of 2, depending upon what you want to call that. And in this particular case, you would let u equal that middle power, x to the 10th, so that this becomes 5u squared plus 2u plus 8 equals 0. And then you would solve for u and then for x in that manner. But however, if you had something like 5x to the 6th plus 2x to the 4th plus 8 equals 0, this is not quadratic type, because 4 is not half of 6. So that's not going to work out there. We can't use this technique. But it will work in weirder situations, right? 5x to the negative 2 plus 2x to the negative 1 plus 8 equals 0. This is quadratic type. We can use this technique, and in this case, u would equal that middle power, x to the negative 1, because negative 1 is half of negative 2. And you can see weirder situations. It can be rational exponents. 5x to the 4/3 plus 2x to the 2/3 plus 8 equals 0. Check. This will work. And in this case, u is equal to x to the 2/3, that middle power, because again, 2/3 is exactly half of 4/3. And even some situations you might not think of, 5x plus 2 square root of x plus 8 equals 0 is also quadratic type. Why is that? Because this is 5x to the first power plus 2x to the 1/2 power plus 8 equals 0, and this is quadratic type because a half is exactly, well, half of 1. And so in this case, you would let u equal the square root of x, or x to the 1/2, and it would become 5u squared plus 2u plus 8 equals 0. And you would go about solving it. So, as long as these powers are in this format, right, coming back up here, this guy is exactly, I don't know why I keep drawing arrows here. Hold on a second. This power is exactly half of this leading power. You're going to be able to use this technique. So let's just do a few examples. We'll do that in the next video.